brief discussion of working right into the homework questions. Hopefully helpful. Any questions? Come and see me. First question involves BOMDAS. Okay, so we've got to focus on doing things in the right order. There are no fractions, there are no brackets or anything like that, but we do have multiply. Okay, we've also got a multiply there and a divide there. And what we do in this case is we completely ignore the plus, because that's right down, addition's right down the end of the list. We're going to do the multiplies and the divides in the order we find them, working from left to right. So the first thing I do is 3/8 is 24. Now what I've done is I've repeated the working down the page. I've now got a 2 times 4 that needs to be done. Okay, so the 24 remains. The 2 times 4 is replaced by an 8, and I've left the divide by 2 in that line there. We then complete it by going 24, and we're going to do the last operation. 8 divided by 2 is 4. So we'll get 24 plus 4, 28. That's the answer there. Question 2. We are multiplying two fractions. Now, we would normally think multiplying is the trickier of the mathematical operation. Normally adding is easy and multiplying is trickier. But with fractions, it's the other way around. When we're multiplying two fractions, we're lucky we can just multiply the numerators and multiply the denominators and get ourselves a new numerator of 3 and a new denominator of 12. And that can be simplified to give us a quarter. If that was addition, if we were trying to add a third to 3/4, we would need to focus on getting common denominators. But in this case, multiplying doesn't need common denominators. Down here, we have two operations, and we actually need to respect BOMDAS here. Okay, the reason for that is there's a couple of operations that need to be done. The first one is that we're going to multiply these two together, get ourselves an answer, and add it to the next. To multiply these two together, we're going to top and bottom, so the numerators become 2, the denominator becomes 6, and we'll end up then with a fairly straightforward fraction addition. What's convenient in this case is that 1/3 is, 3/9 is 1/3, and 2/6 is 1/3. So we'll end up with 2/3 as our answer. With question 4, we've got ourselves unit conversion again. It's the most important line to remember there is that a metre has got 100 centimetres in it. And a question like this can really be done without doing a whole pile of rules. It can be thought of in this way. If you've got 100 centimetres in 1 metre, then in 200 metres, you're going to have 200 lots of 100. Okay, so in this case here, we've multiplied this 1 metre unit by 200, so we have to do the same there. So as you work down the page, we then realise that 200 metres is the same as 20,000, okay, centimetres. That's how we do that one. Question 5, we have, this is a dice, okay, we're throwing a dice, it's got 6 options. The first throw is across the top of the page, the second throw is down the side of the page. And what this tells us is that, for example, throwing a 1 and a 1 gives you a total of 2, okay? And if you scan the entire table across the whole thing, okay, you'll see there's only one way to get a 2, and that's by getting a 1 and a 1. That makes sense. Our question related to what's the probability of getting 11? Well, on this table, there's only 2 places that 11 is possible. Okay, and that is to get a 5 or a 6, or a 6 or a 5. But there's 2 possible ways of getting 11, and there are 6 by 6 or 36 possible outcomes. We end up with 2 on 36, or simplified 1 on 18. Righto, my apologies, this one got a bit bigger. Really need a lot of room, because what we end up discovering is there are 60 possible options all the way down here, okay, covering off 60 possible options. And as I say down the bottom here, you will not get something this big in your exam. But nevertheless, the first out of the draw is red. Is designated by either a red, a red, a red. There are 3 of them, or it could be one of the 2 greens. Okay. There's 5 in the draw, and we're going to pull one out, and it could be any one of them on this line there. Having said that, then, if you first pulled a red out, you then constrain to 4 remaining socks. And what they're going to be depends on what's already been pulled out. In this case, because a red has already been pulled out, we've only got 2 reds remaining, okay? Down here, if we take the most extreme opposite example, we pulled a green out in the first instance, okay? Now there's only 1 green left, and there it is, but 3 reds, okay? Once you total all this up, you'll see it gets a bit small, but these are each of these final lines here is a summary of the 60 possible outcomes. What I've done is marked with a rectangle everything that relates to the red, 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 and I've marked with a dash, like that guy, everything that relates to, with the dash actually relates to question D, where you've got green, green, green and red in any order, okay? So I've scanned the list all the way down, scanned the list, and each of these dots represents a possible answer to that. And if you tally them all up, in that case you get 18 out of 60 or 3 out of 10. The one I jumped was the probability of getting green, green and green, okay? If you actually search through this entire tree, green, green, green is impossible. Okay, it would sit down the bottom here if it was there. And the reason it's impossible to get a green, green, green was there was only 2 green socks in there in the first place. Okay, so the maths is backed up by common sense. But in any case, how do you handle it mathematically? 0 on 60. That is, there are 0 ways you can get green, green, green out of 60. Apologies again for the size of that one. Okay, question 7 gives us fairly directly what the information is. There was a slight typo in the question too, but I think you'll see there's 10 people who basically are interested in netball but not basketball, 12 people who are interested in basketball but not netball, okay, and 2 have an interest in both, and 4 that have an interest in neither, okay. If you add all these numbers up, okay, you'll get how many people there are in our system or in our trial, 28 people. Question 8, straight algebra question. The last 3 are algebraic. In this case here we need to simplify it, and the aim is to get x on its own. So in the end your answer will say something like x equals. And your job is to get all the x's on this side and all the numbers on this side. That's a traditional approach and it works fairly well. In this case here, I've identified that the 4 over there is in the way of x being on its own. It's a plus 4, so I take 4 off both sides. You'll see here the little minus 4. What that allows me to do is on this side here, both of those 4's cancel and I'm left with just 2x. On this side, I get an x minus 10, which is minus 6 minus 4, giving me the minus 10. I then need to effectively remove the x's from the right hand side. I've got this x minus 10. Well, I'm going to take x away from both sides, which will cancel here, so I'm left with minus 10 on this side, and over here I had 2x and I'm minusing x, so I'll get x. I then have my answer. X is negative 10. If you wanted to test this, you would take that value for negative 10 and plug it back up into there and there, and you would test whether you get the right value. And in that case you get negative 16 on both sides, okay, if you do that working. And that confirms that you are in fact on the right track. Question 9, we need to gather together like terms. So you have a 2x, a minus 3x, a plus 2x and a minus x. If you took those 4 terms and totaled them up, you get 0x, okay? And then if you total up the 3, okay, and the 2, you're going to get 5. So our working y equals 0x plus 5 becomes y equals 5. And that's where we get that. Our last question, question 10, it's adding two fractions, which means we need to do a common denominator. To do that, we're going to multiply each side by something. Okay, now in this case, because 5 and 7 won't go into each other, we need to find another number. A good method that's usually quite robust is you have a look at this 7 here and you think, well, you know, if I multiply the other side by 7, I'm going to get 35 on the bottom. If I multiply this side over here by 5, I'll get 35 on the bottom. Okay, and that's where some of you guys have got the idea of cross multiplying, which is this idea that if the 5 times 7 there will give you 35 and the 7 times 5 there will give you 35. Of course, once we multiply the bottom by 7, we need to multiply the top by 7, so by 7 top and bottom, and over here we're multiplying by 5 up there and 5 down there. It's worth recognising that what you're doing here is each fraction, so the fraction we're looking at here, this 3x on 7, okay, when you multiply it by 5 on 5, as we have, you're multiplying that by 1. So you're not changing the size or the value of this side. And similarly over here, when we did it times 7 on the numerator and times 7 on the denominator, this fraction with 7's in it is 1. In any case, we end up with 14x on 35 plus 15x on 35, and we'll get that final answer. And because 29 is actually a prime number, 2, 3, 4, 5, 6, 7, none of them go into 29, so we have to keep that as it is. So let's make common there, can't simplify. That was this week's homework. I hope you've enjoyed yourselves. I've enjoyed presenting this little YouTube video. Apologies for some of the errors in the questions. I'm doing some of this stuff late at night. Hope you guys are getting something out of it. Give me some feedback.